Yes. 491. Okay. Unit 7, Lesson 2, Investigation 1, Law of Sines. Now, if I look at the board, what type of triangle is that, guys? Okay. We don't know, right? Is it a right triangle?
No.
No. There's no little right angle marking, is there? I think someone called it the chair. I don't know if it was this hour or another hour. Okay. There's no chair in any corner, right? Okay. Because it has the little right, it kind of looks like a chair you can sit on. Okay. But there's no right angle marking, right? Right? What principles have we learned for right triangles so far? Or what techniques? Sine, cosine, tangent, right? SOHCAHTOA. Okay? SOHCAHTOA only works for what type of triangles? Right triangles. What else only works for right triangles? Pythagorean theorem. Begins with a P and I can't spell it. Okay? So, Pythagorean theorem and SOHCAHTOA, those only work for right triangles. Is this a right triangle? No. So can we use those? No. We cannot use SOHCAHTOA and Pythagorean theorem in this triangle. Okay? Now, our goal today is to be able to figure out, to be able to solve non-right triangles. All right? Like a non-right triangle like we'll do on page 492, number 4. Okay? That's our goal, is to be able to solve those. We haven't learned how to do that yet, right? Can we use SOHCAHTOA? Can we use SOHCAHTOA? No. Can we use Pythagorean theorem? No, because it's not right triangles. So what we need to use is what's called the law of sines. Okay? The law of sines will work for any triangle, even right triangles. So what we're learning today is going to work for any triangle. Okay, so what we're going to learn today will work for any triangle. Now, in this triangle, the big A, the big B, the big C, what are those? Angles, good. The little a, the little b, the little c, what are those equal? Sides. What? Little a, little b, little c, those are sides. Okay. And that's for anytime we name our triangles, the capital letters are always the angles, the lowercase letters are always the sides. All right? Now the law of sines, if you read on in your book, all right, it tells us that the sine of A over little a, right, equals the sine of big B over little b, or the sine of big C over little c. Now they have an alternate way to write this too in your book, where they flip with all the sides on top and the angles on bottom. You can use that method too. I just like to remember this one, all right, because I don't want to get confused by trying to remember two of them. All right, so I always use it this way. You can write it any way you want though, but that's the law of sines. Now you're probably looking at this and saying, "Whoa, an equation with two equal signs, right, John? Are we a little intimidated by an equation with two equal signs? No? Okay, why not? Last hour was a little bit.
Because we're not last.
You're not last hour. You're not afraid of anything, right, Josh? Okay, now this equation, it shows a relationship between this angle and its corresponding side. Okay? It's basically telling us that the ratio of this angle over this side is equal to the ratio of this angle over this side and this angle over this side. It's kind of like ratios like we do to sine, cosine, tangent to begin with. Right? Now what's cool about this equation is you can pick and choose the pieces you need. Okay? Let's say we know big A and little a, and we know big B and we want to find little b. Okay? Then I can cover this part up and just use those two. Okay? Or let's say we know big B and little b. We know big C and we want to find little c. I can just use those two. Okay? Or if we know big A, little a, and little c, and we want to find big C, then I can just use those ones. Right? So as we're using this equation, just use the two parts you need. Okay? You have to use 2 out of 3. Now you can't mix and match though. Okay? I can't do big B over little c. Okay? Because then you're changing the equation. All right? But just pick 2 of the 3 that you need. So don't be intimidated by the 2 equal signs. Just pick the two that you need. All right? Does that make sense? Does that make sense, guys?
Yeah.
Okay. Now, in order to make this equation work, how many unknowns can we solve for? 1. Anytime I have an equation, I can only solve for one unknown, right? So if I'm looking at a problem like this one, sine of A over little a equals sine of B over little b, right? I have to know 3 of the 4 things, don't I?
Yeah.
Like I have to know big A and little a, and if I know big B, then I can find little b, right? So in order to use the law of sines, you need to have at least one angle side pair. Okay? So to use this, we need at least one angle side pair. Now, what do I mean by angle side pair? Anybody know? What was it? Big B, little b. Good. Big B, little b, that's one angle side pair.
Big
Okay.
A, little A.
Okay, or? Okay, good. So that means I need to know at least one of these combinations. I need to know big B and little b, big A and little a, or big C and little c. If I'm given a triangle where I don't know an angle side pair, then we're going to use what's called the law of cosines, and we'll learn that on Monday. Okay? So law of sines, we need to know at least one angle side pair. Otherwise, you got to use the law of cosines. That'll be the sequel to this on Monday. You guys look very excited for the sequel. Yeah, thank you. Appreciate that. You don't forget over the weekend. That's all right. I'll put some on Facebook for you. All right. Are there any questions about the law of sines? Any questions? Okay. If you look at number 4, page 492. If you don't have your books, I drew the triangle on the board for you. All right. We are going to solve this triangle. Okay. So solving this triangle means we need to find everything we don't know. Right? So what don't we know? Okay, we don't know little b, little a, and big C. Okay, is this the right triangle? No. So can I use SOHCAHTOA? No. Can I use Pythagorean theorem? No. Now, I said we need to know an angle side pair in order to use law of cosines. Right? Do we know an angle side pair in this triangle? No. So you guys are all thinking, Mr. Branch, you messed it up already. Right? Okay. Maybe. I do have a trick. I got on sleeves though. Small trick. Hey, I got good jokes, right? Okay. So here's the small trick. If I look, that's a triangle, right? Right? What rule works for every triangle besides law of sines?
180.
All the angles equal 180, right? So even though we don't know C right now, can we find it? Yeah. Told you it was a little trick. So how do I find C? We had 64 and 34, then do what with those? Subtract it from 180, good. So we know C equals 180 minus 64 minus 34, right? Right? So what does C equal? 82? Okay. Told you a little trick, right, Mark? Yeah. Okay. So, yeah, sometimes. So big C is 82. Now, do I have an angle side pair? Yeah, which one? C and little c. Good. So now I can use law of now I can use law of sines. We'll do cosines on Monday. I can use law of sines to find either little a or little b. Do you guys think it matters where I start? I can pick whichever one I want to start with. Okay. So what do you guys want to start with, A or B?
A.
Okay, I heard A first. So we'll start with A. So I'm going to use law of sines to find A. Okay? I know C and little c. I want to find A. So do I have to use the B and little b? No, I can just cover that up. Okay, and I'm going to use this equation. Sine of A over little a equals sine of C over little c. Okay? So sine of A over little a equals sine of C over little c. So that's what I'm going to use to find little a. Now I can plug in what I know. Okay, what is big A? 64. So sine 64 over little a equals sine of, what's big C? 82. What's little c? 2.68. So sine of 64 over A equals sine of A2 over 2.68. Now I said we couldn't use SOHCAHTOA, but can we still calculate sine? Yeah, we can still calculate sine. So our first step here is going to be calculate sine of 64 and sine of A2. So make sure your calculator's in degrees and hit sine 64, sine A2. Okay. Yeah, so make sure it's in degrees. I heard someone say, what was sine of 64? 0.89. Okay, so we'll call it 0.899. Okay. That's over A. And what's the sine of 82? 0.990, right? Okay. Now, whenever we take the sine of something that's close to 90, so like 91, 92, all up to 100, or 80 to 90, anytime we take the sine of something close to 90, it's going to be close to 1. Okay? But I can't put 1 in here, because if I put 1 in there, that means I use the 90-degree angle. So even though this is 0.990, resist the temptation to round it to 1. Okay? Whenever it's close to 1, we got to make sure it's not 1. Okay? Don't round to 1. Right? So if this isn't a 90-degree angle, then we can't have that be 1. Okay? If it's like an 89-degree angle, it's going to be like 0.999999 something. Okay? Make sure you write it all the way out. Right? Because if you round it to 1, that means you just turned it into a right triangle. All right? We can't just turn it into right triangles. Right? And then 2.68 doesn't change. Now, I heard somebody predict what we got to do next already. Okay? Oh. This could be either a one-step or a two-step process here. I like the one-step process. We got to get the A by itself, but to get the A by itself, we got to do what I call the coolest mathematical operation. Does anybody know what that is?
Sleep.
No, that's not a mathematical operation. It's a biological one. The coolest mathematical operation. John, you said it earlier. What'd you say? Oh, my goodness. Come on, Sleepy. You said cross multiply.
Oh, yeah.
Right? Remember whenever we have two fractions, we can cross multiply?
No.
No, you don't remember that? Okay, well, I'll teach you something new then.
I thought I was
Okay.
wrong.
In order to simplify this, in order to get rid of my fractions, I take what's on bottom over here, multiply what's on top over here. Okay? I take what's on bottom over here, multiply by what's on top over there, and then I get rid of my fractions. No more fractions. Kind of cool, huh?
No.
No, I think it's cool because it has an X in it, like X
Yeah,
Games,
that's not cool.
you know, or X Files. That's an old TV show. Okay.
That's how you know you're old.
I know.
And you know how most kids actually know what you're talking about.
You're working on it. Ex-boyfriend, Davion? Is that what you said? Oh, okay. So maybe everything with X in it isn't that cool, right? Okay, we're going back to math. All right. So 0.899 times 2.68 equals 0.990 times A. Coolest mathematical operation ever, in my opinion. But I'm kind of nerdy.
I thought I was wrong. You didn't say nothing, so I was just
I was waiting for it. I was going to come back to you. Okay. So 0.899 times 2.68. What does that equal? 2.41. Okay, I'm going to move up here so that you guys can see back there. So we got 2.41 A equal, or not A, whoa,
Right?
what am I doing?
I know if you do that, then we can't see it.
2.41, I'll move, equals 0.990A. Okay, so 2.41 equals 0.990A. Now I know it has decimals in it, but what if I turn this difficult problem into algebra, one-step algebra problem, right? So cross multiplication took a difficult fraction equals fraction problem and turned it into a one-step algebra problem. You see why it's cool, Josh?
No.
You see why it's useful?
Yeah.
Okay. I still think it's cool. Okay. So, how do I find A now? Divide by what? Divide by 0.990. So nulls cancel. We get A equals something. What is it? 2.43. Any questions? Any questions?
Why is that 2.43?
Because 2.41 divided by 0.990 is 2.43. Does that make sense?
Yes.
Yeah? Okay. Now, if I was doing this problem, we had to solve it, right, Matt?
What? Yeah.
We had to solve it. We had to find everything we don't know. Now, if I was doing this problem, I would take this 2.43 and I'd write it next to little a. Because that way when I'm looking at this problem, I can say, oh, I can use little a now too. Right? Because the next thing we got to find is little b. So what I would like you guys to do, okay, is I want you to try to find little b. Okay? I want you to try to find little b. Okay? And I'll make my way around the room, so if we need help, ask for help. Okay? Now, do I have to use big C and little c?
Yes, because no, you don't. You have
Good. I have two pairs here, right? I have big C and little c. I also have big A and little a, right? So now you have options, don't you? You can use big A and little a, Matt, with big B and little b. Or you can use big C and little c with big B and little b. Okay? So you have options. You can pick which way you do it. So you and the person next to you might not do this one the same way. Right? And that's okay. Variation, variety, not variation. Variety is the spice of life. Right? Try this one out. Get it on the table. Make sure you erase it. Josh, I get some paper. What are you doing? Tony, what are you doing? What? Sit in here, I see that. You just got a practice problem? Why not? Being awake and paying attention is going to help. You're welcome. Okay, if you need help, guys, please let me know. Okay, this shouldn't take us too long, all right? We'll go with like 4 minutes, 3 or 4 minutes. Okay.
What trick function do we use?
Well, is it a right triangle?
No.
So can I use SOHCAHTOA? No. So what do you have to use?
Oh.
Nope. Pythagorean theorem only works for right triangles. So what do you have to use? Law of sines. Okay. Do you want to use big A and little a or big C and little c? It doesn't. Aaron, which one do you want to use? Big A and little a or big C and little c? Big C and little c? Okay, so then you're going to use this equation. Sine b over little b equals sine c over little c. Fill in what you know and solve what you know. Got a question? A pen? Would you prefer a pen?
It's not collateral. It is. Here's the thing with the yo-yo.
It's entertainment.
That you're old.
I'm not good at yo-yoing. I'm not gonna lie. I'm good at oh-yoing though.
You're fine.
Brad, you should just need to stop trying to crack jokes.
I'm not trying.
I say none of them are funny.
You guys laugh.
I didn't.
Fine.
I
It's
did.
all my
Fine
word.
B?
What did I do?
Okay. Then men. Okay, do you want to use big A? Yep, do that again. But instead of using A, we use B.
It's supposed to be
Right.
Okay. We're supposed to be ranked like all weekend.
Need help? Let me know.
60% from the people. 60%.
Guys, it's okay if you talk to the person next to you because you're working on the problem.
Thank you. Jonathan, just keep your voice down.
Okay, guys, a minute. A minute, and then we're gonna go over it. Yeah, I'll even turn the timer and make sure you're going up. No, do 0.559 and 0.8. Thank you.
Oh yeah.
Does anyone want to show us what they did on the board? In a minute. Aaron, you want to show us?
No, I need to.
What question? Okay, head up there. Use one of the markers that has a green dot on the back. Okay, and write it big underneath the projector screen. Yep. Are there different answers? I'll look you around in a second.
That's
Good. What'd you get?
Still think
What'd you get? What'd you get?
I think
Did you all round it?
I'll be big.
Did you use 3 seconds or 3? Okay. How many decimals?
Three.
I got 1.51. So sign of 34. Oh, that's why it's 62.
Let's 82
or 64. Because if you're using 2.68, that's little c, right? So you use 82. Yeah, you said it right. But this is 5.5. 5.6 or 0.55. Just outside the screen here, Trey.
am I really?
That's okay. I'll just turn it. It's fine.
Oh, I did.
You're doing
I
great
need
though.
some TV time.
I don't know what
I could trace some TV. Introducing Trey
Man,
Sham.
that boy fly. He fly. Better not get this question wrong. So,
Oh, laugh if you got it wrong on camera. Make my mom watch it.
All right, guys. Trey is showing us what he did. Trey is showing us what he did. Now, while he's finishing up, some of you are noticing as you compare with your neighbors that how you round makes a big difference. Okay? How you round makes a big difference. I would keep at least 3 digits. Okay, when you're rounding. Okay, keep at least 3 digits. Okay? Nice job, Trey.
Thank you very much.
So Trey got B as 1.5. Okay? That's right. When I did mine, I got 1.51, but I didn't use C, I used A and little a. Okay? But that's okay. You get close. Okay? Like I said, rounding makes a difference. So as long as you're close to the right answer and you show me your work, then you're going to get it right. Okay? So Trey did it exactly right. So sine of big B over little b, sine of 34 over little b, equals sine of big C over little c, sine of 82 over 2.68. He then figured what sine of 34 and 82 were. Cross multiplied, divided by 0.98, and got 1.50. Okay. Are there any questions on how I did this one? Any questions on law of sines?
No.
Okay, nice job, Trey. All right, can we give a round of applause? There we go.
Oh,